Hello, welcome back to this session, viewers. Yesterday we began with the topic rational numbers. We started discussing on rational numbers, and before discussing that I gave you some idea about how this national curriculum framework, what it exactly expects from you and why should we read about these mathematics topics whatever are given in the textbook and how these topics are related to each other. We need to focus on one of the topics and then see how they are extended further and how they are used in other areas as well. For example, when you study the concept of ratio and proportion, the concept of unitary methods come into light, and then you get the concept of percentages, and percentages is an important thing that is used everywhere in profit and loss, simple interest, compound interest, and many of the concepts that you find around you, percentage increase, percentage decrease, and so on and so forth. And one of these concepts that we yesterday tried to discuss was the rational numbers from class 8. Now, continuing our topic, because yesterday I just gave you an overview of rational numbers. Rational numbers you have already studied in class 7, I know that, and so now I would like to continue this further with some problems or some queries, some questions that will involve you in the thinking process. See, it is important to be involved in the thinking process and try to develop something for yourself, and see that you share your thoughts with your friends, with your relatives, with your teachers, and see how your vocabulary and understanding of mathematics grows. And that particular growth in your understanding will make you feel confident about doing mathematics. Never be scared of discussing it with others just for the sake that someone might say that you do not know mathematics or you do not know this particular sum. It is nothing like that. You just try to convince them with your arguments. If you feel that whatever arguments you are doing are not in consonance with whatever you have done earlier, try to think about it, try to check in your concepts, and then of course be frank to confess that yes, I did not use this or I did not know this. That is more important, and then it becomes easier for you to grapple with mathematics. Otherwise, mathematics is not merely a jumble of algorithms, it becomes a smooth way for knowing different concepts and the related things about them. So, today I will just start with a problem that you might have attempted in your earlier classes also. You have seen these numbers 2 integer 1 by 5 and 3 integer 2 by 15. Are they rational numbers? Yes, they are rational numbers. Which kind of rational numbers are they? They are positive rational numbers. Now, if I want to add them, what is the procedure you follow normally? You convert this into improper form, that is, you convert this to the form 5 multiplied by 2 plus 1 whole upon 5, that is equal to 11 by 5. This becomes an improper fraction or a rational number in this improper form. This particular thing can be converted to 15 multiplied by 3 plus 2 whole upon 15, and so you get here 45 plus 2 47 divided by 15. And now, when I ask you to add these two rational numbers, what you will do? You will add these two improper fractions, that is 11 by 5 plus 47 by 15, and you have got your regular process of finding LCM and then converting them to the equivalent forms and then adding them. So, the LCM of the denominators is 15. So, I will convert both of them into the form of 15. The first one, the first fraction, the first rational number, I will convert into an equivalent rational number with denominator 15. So, what will I do here? I will multiply the numerator as well as the denominator, multiply the numerator as well as the denominator by 3, and here of course 15 is already there. So, I can say this is 47 by 15, and then I can say 33 plus 47 divided by 15. That is the regular process you follow. But if I ask you to add them without converting it into an improper fraction, without converting them to improper form, how will you do that? And a little knowledge about mixed fraction and how they are formed comes into use here. See, whatever you have studied in fractions, that is coming to the use here now. How are you able to see this? Merely converting into improper form is not sufficient. Let me check this now. 2 integer 1 by 5 and the other one was 3 integer 2 by 15. What do I understand with this? This is nothing but 2 plus 1 by 5. you check it, you convert it into that particular form, you will again get 11 by 5. So, this is 2 plus 1 by 5, 2 and 1 by 5, we mathematically write it as 2 plus 1 by 5. This also 3 and 2 by 15. So, I can write this as 3 plus 2 by 15. So, the other application, this is an application of what you have studied, not merely converting into improper form, but you can do it this way also, if it is easier for you to do that. And so, if I say now 2 integer 1 by 5 plus 3 integer 2 by 15 can be written as 2 plus 1 by 5 plus 3 plus 2 by 15. And here now I can add the whole number parts, 5 plus 1 by 5 plus 2 by 15, this can be written as 5 plus 3 plus 2 divided by 15, and that comes to 5 by 15 or 1 by 3. So, in this way you can add the fractional parts, you can add the whole number parts, and then again convert it back to the fractional part, that is the rational number part, that is 5 integer 1 by 3. Because it is a positive rational number, so I can dare to say that this is a fraction also, but otherwise a rational number is a more general set, is a more general collection of numbers that includes the negatives of these also. And of course, you know how to add the integers, negative integers, positive integers and so on. So, you can operate upon that also. The purpose of solving this question was, it is not necessary that you should solve a particular or attempt a particular question or think about that particular idea in only one way. You have got different ways of doing that, and in using those ways you are able to apply the different concepts, you are able to apply the same idea in a different angles. So, here I could see 5 integer 1 by 5 as 5 plus 1 by 5, or the original number was 2 integer 1 by 5. So, I was able to see it as 2 plus 1 by 5 or 2 integer 1 by 5, the whole number part is 2, or you can say the integral part is 2 and the fractional part is 1 by 5. So, this is one of the ways in which we can also attempt such a type of question if it comes to us. Yesterday we had seen something about standard form. What is the standard form of a rational number? I say that the rational number p by q, where p and q are integers and q is not equal to 0, is in the standard form if they do not have any common factors other than 1, that is they are co-primes, and q should not be negative, q should not be negative, that is 2 upon minus 3, I will not say that this is in the standard form. Similarly, 10 by 15, I will not say that this is in the standard form, because you have got 5 as the common factor here. 5 is the common factor for 10 and 5 is the common factor for 15 as well. So, this is not in the standard form, but I can write that 3 by 4 is in the standard form, minus 7 by 8 is in the standard form. It is a negative rational number, there are no common factors other than 1 in both these cases, and the denominators are positive, they are not negative. So, these are standard forms. So, what I wanted to do for you is, you convert this particular rational number minus 48 by 60, minus 48 by 60, try to first of all see whether it is in standard form or not. If it is not in the standard form, try to convert this into standard form. So, every rational number that is given to you may not be in that particular form, you have to first try to convert it to standard forms and then you can operate with it. In the higher classes, when you come across some more concepts, there you are required to convert a rational number into standard form and then you have to proceed further. So, that is why we should know how should we proceed to convert it to standard form as well. Now, you can see here that the denominator is positive. So, there is nothing to be done here. Then what is to be done? You have to see what is the greatest common factor or highest common factor of these two numbers and then try to divide it, the numerator as well as denominator, by that highest common factor and convert it into the equivalent form. I find that the highest common factor of both these numbers is 12, and so I can say that if I divide both of these by 12, for minus 48 divided by 12 upon 60 divided by 12, what do you get? You get here minus 4 and you get here 5. So, I have divided numerator as well as denominator by their highest common factor, and I find that I get this in this form. Now, check for the validity of this. Denominator is positive, it is not negative, and the highest common factor of these two numbers 4 and 5 is 1. So, therefore, this has been reduced to the standard form. So, we need to know how to convert the rational numbers in the standard form also. First of all, we should know what is the standard form and try to attempt as many such questions as possible from your textbook, so that you get idea of the standard form. Now, I am giving you some statements. Whatever we have studied till now about rational numbers, we need to apply that also, and when we try to apply it, we get some more information, we are able to generate some more ideas as well. I am stating here I am making some statement, writing some statements here. Let us see whether these statements are true or not. If they are not true, why they are not true, right, and how to improve upon them to make it true. So, my first statement is, every rational number is a whole number. If you have any examples for this, try to generate it. You might say that 2 is a rational number and 2 is also a whole number. 0 is a rational number and 0 is also a whole number. But friends, this is the language of mathematics, where if you want to disprove a statement that it is not true, you need just one example. Hundreds of examples I can give for this. 2 is there, 0 is there, 5 is there, 10 is there, you can give lots of examples, but one example will suffice, if at all it exists, to show that every rational number need not be a whole number. And so, I take this example as, say, -1. -1 is a rational number and -1 is not a whole number. 2/3 is a rational number, 2/3 is not a whole number. So, now what can you say about this statement? This statement is not true, this statement is false. So, how can I correct this particular statement? There are rational numbers which can be whole numbers. There are rational numbers which can be whole number. We cannot say every. This word every cannot be there. But can you say the other way around, that every whole number is a rational number? That is the thing. So, my next statement would be, if I turn it the other way around, that every whole number is a rational number. If I make this particular statement, then as I discussed yesterday, if I take the number, say, 0, I can write it in the form 0/5, it becomes a rational number. If I take the number 2, I can write it in the form 4/2 or 6/3 or 8/4, they are in the rational number form, because numerator and denominator both are integers and denominator is not equal to 0. So, every whole number whatever you take, try to find whole number which is not a rational number, and that can be an exercise, mind boggling exercise for you. You might get interested in that, but as far as the statement goes, the thing is every whole number is a rational number, right. Now, some such statements, when you try to understand them, it is not merely the words that are important, it is the logic of mathematics that goes behind it. The use of the word every, that is more important. Even if you suppose give an example which is in favor of that, that is not going to work, because I might create an example which is not in favor of that, and so that statement becomes false. Another statement is, every integer is a rational number. Every integer is a rational number. Can you verify this for yourself? Suppose I take the integer -7, I can write this -7 as -7/1 or -14/2. There are several ways of writing that. Try to express it for yourself, and you can see that numerator and denominator both are integers and denominator is not equal to 0. This becomes a rational number, and so we can say that every integer is a rational number. Every whole number is a natural number. See, we have studied different number systems till now: natural number, whole number, integers, and now we have come to rational numbers. And you will find that through these statements, try to compare these number systems, try to see that the collection of these numbers, which collection is contained in the other collection, and you will find that rational number system will be the largest of all these. Every whole number is a natural number, I am saying now. Can you say that every whole number is a natural number? I have got the numbers like 1, 2, 3, 4 and so on. They are whole numbers and they are natural numbers as well. but there goes one more thing, there is one more element that is left out here, that is 0. Can you say that 0 is a natural number? No, 0 is not a natural number. So, we cannot say that every, see I was trying to emphasize on the word every. The moment you say every, this particular 0 is going to create problem. Had it been simply these numbers, then you could have said that, but now we cannot say that every whole number is a natural number. So, the statement is false. Every whole number need not be, do not say is not, because if I quote this number, it is a natural number. So, it need not be a natural number. Every natural number is a rational number. Yes, you can see here, these are natural numbers, 4 is a natural number, 3 is a natural number. We have seen this, that how these can be expressed in a fractional form. 4 can be written as 8 by 2, or it can be written as 12 by 3, and so on. Is every natural number an integer? See, you have got 4 number systems you have studied till now. You have studied natural numbers, you have also come across whole numbers, and you have come across integers, and now the rational numbers. Try to compare these number systems, try to compare these collections of numbers. Every natural number is a whole number, every whole number will be an integer, and every integer is a rational number. Will it go the other way around? Will it, can you say that every rational number is an integer? Will every integer be a whole number? Will every whole number be a natural number? Try to see the reverse trend, and you will find for yourself the difference between these collection of numbers. As we are proceeding further, we are proceeding for the larger collections of numbers, because these numbers, as I said earlier also, that whatever situation comes before you, whatever things are present in your environment, those things demand the coding in terms of numbers, and so different concepts of mathematics are generated, and these generation of the number systems is one of the concepts that we are dealing here. It is not just the number system or arithmetic, it is one of the whole part of mathematics that is being studied. Now, let us proceed further with one more example. So, we have tried to see how these collection of numbers, how they are proceeding further, and the largest of these collection is the rational numbers that we are studying here now. Rational number forms an important part of mathematics. Later on, some more numbers will be added to our collection, because as I said, the situation demands that. So, I will just, in order to deepen our understanding of mathematics, let us try to see it, because what is the other source of doing it? Unless and until we have problems before us, and unless and until we try to think on those problems, our understanding of the concepts that we have studied will not be clarified. So, I am just taking one example here. We take x is equal to say minus 4 by 9, y is equal to, I am taking this as 5 by 12, and z is equal to 7 by 18. I am talking now in terms of some literal, some number. I am giving them x, y, z. X is one rational number, y is another rational number, z is third rational number. Now, my first statement goes like this: the rational number, you have to find a rational number which when added to x gives y. Rational number, you have to find a rational number which when added to x gives y. Try to think over this. You have to add, try to see the words first of all, whatever are written here. You have to find a rational number, find a rational number that when added to x gives y. So, I can write x plus something, or you can say, if you have solved equations and you know this, you can write here a as well, and I can say that x plus something, x plus some number, rational number is equal to y. Now, what is our x? X is nothing but minus 4 by 9 plus a is equal to, what is y? Y is nothing but 5 by 12. So, I have to find the value of a, I have to find that particular number which when added to this will give me this. So, let us try to do that. You know how to solve the equations. So, what I am doing? I am shifting minus 4 by 9 to that side means I am subtracting minus 4 by 9 from both sides, that is minus 4 by 9 plus a. Now, since this is already minus 4 by 9, I need a number which when added to minus 4 by 9 or subtracted from minus 4 by 9 will give me 0 on the left hand side, and the obvious choice before me is I add 4 by 9 here, because I know minus 4 by 9 plus 4 by 9 they are going to give me 0, and so I can say that this is 5 by 12 plus 4 by 9, and so I get here, since these two get cancelled and get 0, this will be equal to, I can find the LCM of both these numbers and I can say that this is 36. So, this is 15 plus 16, that is 31 by 36. So, if this particular number is added to minus 4 by 9, that is when I say minus 4 by 9 plus 31 by 36, this is going to give me the number 5 by 12, that is y. Let us check it. Again I get the LCM as 36. So, this becomes minus 16 plus 31 and I get here, how much is this? 15 by 36. Is it okay? I have got this number as 15 by 36 here, and if you reduce this number, that is you divide numerator and denominator by 3, I will get here 5 by 12, and this is nothing but y. So, the number that is to be added to minus 4 by 9 is 31 by 36. These are the common statements that you might get. What is the number that when added to x will give you z? You can follow this particular procedure. If you are comfortable or with directly transposing the numbers, if you are comfortable with that, but by transposing you should have a clear idea that you are either subtracting or adding or dividing or multiplying by a suitable number, and that particular thing will take you that number to the other side of the equality sign. So, before using the word transpose, try to see that you understand what does it mean. Before using the word transfer of a number from one side LHS to RHS, try to understand what it exactly means, and then you can use these words very comfortably. So, now I will present before you one more example here, the reciprocal of x plus y. The reciprocal of x plus y. You know what is the reciprocal of a rational number. Suppose I take the rational number as 2 by or minus 2 by 3. Minus 2 by 3, the reciprocal of this number, rational number, is the number 3 by minus 2, or in the standard form I can say minus 3 by 2. How did I get this particular thing? I multiply numerator and denominator by minus 1 because I want this in the standard form. This is not in the standard form. Negative number is appearing here, negative integer is appearing here. So, to make this positive, I multiply both of them by minus 1 and I get this. So, this is the reciprocal of. So, why this is 3 by minus 2? Is it in the standard form? This is not in the standard form, because minus 2, the negative integer is appearing in the denominator. So, to make it positive, I multiply numerator and denominator both by minus 1. Whatever operation you have to perform, that you have to perform in the numerator as well as denominator. If while solving an equation, whatever operation with a number you perform, you have to perform on both sides of the equation to retain the balance of that equation. Similarly, here also, to retain the value of that particular fraction or the rational number, you need to multiply or divide in the numerator as well as the denominator. So, the thing was, this is the reciprocal of this number, and how do we test it? We multiply it, multiply minus 2 by 3 and minus 3 by 2 and see what you get. I will discuss it sometimes later. At the moment, my question is, I want the reciprocal of x plus y. How will you find the reciprocal of x plus y? You know the value of x, it is nothing but minus 4 by 9, you know the value of y, that is nothing but 5 by 12, and using your regular methods of addition of rational numbers, you can find out a number and then take the reciprocal of that. That is, this number is nothing but, just now I have shown this, minus 16 plus 15, and that is nothing but 1 by 36. So, I get x plus y as minus 1 by 36, and this minus 1 by 36 What is my question? Question is, I want the reciprocal of x plus y. What is the value of x plus y? Minus 1 by 36. So, what is the reciprocal of this? This is nothing but 36 upon minus 1, or I can say it is simply minus 36. So, when you multiply minus 1 by 36 and minus 36, you are going to get 1. How you get it? You know the multiplication of rational numbers. So, in this way we can express the numbers in different forms, try to add them, try to subtract them, but when the addition, subtraction and all these operations are mentioned in words, try to understand these words first, try to understand the statements that are given, and then accordingly one by one try to break it up into pieces and try to understand each of these pieces and then work upon it. You will arrive at the solution. If at all you get stuck up somewhere, try to go back and revisit your earlier learned concepts. Now, what I wanted is, what should be added? My other question is, just to give you more understanding about the concepts of integers and rational numbers, one statement is there, what should be added to minus 1 by 2? What should be added to minus 1 by 2 to obtain the nearest natural number? To obtain the nearest natural number. When I want to see which is the nearest natural number, the different number systems, when we try to extend the number systems, when we try to extend the collection of numbers, the same number that was called natural number in the natural number collection can be called as a positive integer in the integral collections. What will you call it in terms of whole number? Suppose I take a number 2. Number 2 I can call a natural number. Number 2 I can call a non-zero whole number. Number 2 I can call a positive integer. Number 2 I can call a positive rational number with denominator 1. So, we should be able to speak about that particular concept in different ways, and then you are able to relate how these numbers are relate the numbers to each other, and this is what is important. Now, minus 1 by 2 is there. I try to represent this on the number line. I will try to represent this on the number line. This is 0 here, this is 1 and this is minus 1. Where do you think I should put minus 1 by 2? Minus 1 by 2 will be somewhere in between, that is exactly at the midpoint of 0 and minus 1. So, minus 1 by 2 is here. Now, which is the nearest natural number to this? The nearest natural number you can see is 1. It means that minus 1 by 2 has to be converted to 1 by adding or subtracting some number, and that is what they are asked, that what should be added to minus 1 by 2 to get 1. Again I make use of equation, I make use of variable, because that becomes more simpler for me to solve it, and so I get here x is equal to 1 minus of minus 1 by 2, and that is equal to, I will not simplify it at the moment here because I assume that you know this, that is 1 plus 1 by 2, that is equal to 3 by 2. 3 by 2 when you add, you get 1 here. This is one way of looking at the problem. Another way could be, when you say 3 by 2 means 3 jumps of 1 by 2, 3 jumps of 1 by 2, 1 by 2, 1 by 2 to the right. While adding rational numbers, we follow this convention on the number line. So, look at this here, 1 by 2, here also there is 1 by 2, 1 by 2, 1 by 2. How many jumps are there? 3 jumps are there. Without doing this also, you can do this. In this way also, you can get an idea of what should be added to minus 1 by 2 to get 1. So, this is one of the ways. In our other sessions, we will try to explore some more such statements and try to see it is not just the conventional methods that you do of addition subtraction, but how to look at the problem in a slightly different way also, that is important. In this session, we have tried to discuss, we carried forward the things that we did yesterday, some concepts of rational numbers were reviewed, and based on that today I discussed with you some problems and tried to relate the rational numbers with the numbers that you have studied in the earlier classes. So, that is all for the day. I will continue this particular discussion in our next other sessions also. Thank you so much for the day.